Let's look at a practice problem. The first thing you should do is write down the information the problem gives you. So we have a sample of gas collected in a 350 milliliter container. Hopefully we know that the unit milliliter tells us that this is a volume. And since it's the first one we were given, we can say it's V1. Doesn't matter which one you make 1 and which one you make 2, as long as you connect the variables the correct way. So at 350 milliliters, it exerts a pressure of 103 kPa. So that is our P1, our pressure at the same time that our volume is 350. It asks what would the volume of this gas be, so we know that's what we're looking for. What would be the volume at 150 kPa? And it's written, assume that the temperature remains constant. Units don't matter so much as long as they match. So because both of my pressures are in kPa, are in kilopascals, it's fine. We don't have to do any converting. We can look at this list of what we know and what we're looking for and see that we should use Boyle's law. And I like to write my equations first so that I remember them. P1, V1 equals P2, V2. If we're trying to solve for V2, we're going to divide both sides by P2. And we get V2 equals P1, V1 divided by P2. So when we plug our numbers into our equation, and you don't have to show me this part, but you do have to show me this right here. I need to know what math you're doing so that if you're making mistakes, I can help you figure out how to fix them. And I like to start by looking at my units to make sure I've set this up right. And we can see kPa cancels out and we're left with milliliters, which makes sense if we're solving for a volume. So now we do the math, the 103 times 350 divided by 150. And your calculator should say 240.333. Let's talk significant figures so we know where to round this number. This has 2, this has 3, and this has 2. So we're going to round our number to 240 milliliters. Let's look at another example. In this example, we're told a sample of neon has a volume of 239 milliliters at 2.00 atm of pressure. What would the pressure have to be in order for the gas to have a volume of 5.00 times 10 to the second milliliters? So we should start by writing down what we know and what the problem gives us. Say V1 is 239 milliliters, and at this volume, the pressure is 2.00 atmospheres. The second volume is 5.00 times 10 to the second milliliters, and we're asked to solve for the second pressure. You can put this number into your calculator like this, or you can realize that this is just 500 milliliters. It's written in scientific notation so that you have 3 significant figures. When we look at this list of what we know and what we're solving for, we can see we're going to use Boyle's law. I know right now that's the only one you know, but on your test, I'm not going to tell you. So this listing what you know and what you're asked for helps you decide which equation you should be using. So I have P1 times V1 equals P2 times V2. And if we're solving for P2, we're going to divide both sides by V2. So we get this. Again, you don't have to show me that part. You do have to show me the rest of this. We plug our numbers into our equation. And we can see our milliliters cancels out, giving us atmospheres, which is good because that's pressure. And now we can do 2 times 239 divided by 500. And your calculator should say 0.956. And let's talk significant figures. We have 3, 3, and 3. So we're actually going to keep the entire number. 956 atmospheres.